Translation of source code to machine code. Computers can only read binary, or machine language, and while humans can read binary, it is very inefficient. Thus, humans need a program in a higher level language in which they can easily read and understand. But as computers cannot understand this, they need to be translated back into machine language to perform anything useful. When learning how to program, your source code is usually automatically translated by an integrated development environment and hides the process of translating from source code to machine code. At a low level, processors can perform basic math operations with numbers they store in memory, but they can perform more useful functions by being programmed. But how exactly is a CPU programmed? So there are stages of translation, which begins with pre-processing and moves on to compilation, and then machine code generation and the linking stage. The pre-processing stage deals with the cutting of source code from one file and pasting it to another file. The compilation stage deals with generation of assembly code, which itself contains many stages. When the assembly code is generated, the machine code generation stage is initiated, in which the produced assembly code is finally translated into binary that can be understood and executed by the CPU. Finally, the linking stage is taking all parts of the source code and linking it together into one executable file. A more in-depth analysis of this is that it begins with the lexical analysis. The process of lexing takes the text of a high-level language and breaks it down into lexemes, and then maps these lexemes into tokens such as keywords, identifiers, literals, operators, special symbols, and constants. But before these are broken down, tokens are a pair consisting of a token name and token value. Lexemes, which are a sequence of alphanumeric characters from the source code to match the pattern of the token, and is identified by the lexical analyzer to be the instantiation of that token. Moreover, these stream of tokens will be fed into a syntax analyzer. The next stage is the syntactical analysis. It converts a sequence of tokens into the parse tree, a data structure that organizes these tokens into hierarchical structures, analogous to figuring out what the grammar is of the source code. It then contextualizes these, in which the compiler records the context about the program, including the variable names and the function names. Finally, it converts all of these outputs into binary and can then instruct the CPU on how to function.
Compilers. What is a compiler? A compiler is a program with the ability to compile code. That is, it can translate high-level source code written in languages such as C, C++, Java, and Perl. Compilation is a process of translating source code which we use to create programs, such as C# and Java, into machine code, which the machine can read such as binary, consisting of zeros and ones. Types of compilers include native code compilers. Native compilers compile code native to its language and delivered in bytecode. Cross compilers, able to compile source code to multiple platforms. Source-to-source compilers, able to take in high-level source code as input, then output back high-level language source code. Advantages of compilers: efficient and quicker, increased performance, and hard to revert back to source code. Disadvantages of using a compiler: platform-specific, longer compilation times. If more code is present to compile for another operating system, you will need to recompile it. These are some examples of compilers.
An interpreter converts high-level source language into machine code that is in an intermediate level language that is easy to execute. In contrast with compilers, the source code is translated line by line and executed simultaneously, making the process significantly slower. Because of this, interpreters are often used in debugging and training, areas where speed does not matter. However, interpreters do not generate intermediate object code, hence taking up less memory in the process. One main advantage of using an interpreter is platform independence. This means that the program can be executed regardless of the operating system without requiring any modification. For example, you can compile a file into Java bytecode and then interpret the same file in a different machine archetype through Java Virtual Machine. There are several types of interpreters that work in different ways. Abstract syntax tree interpreters transforms the code into an abstract syntax tree, then execute the code following this structure. Other examples include bytecode interpreters, which use bytecode, threaded code interpreters, just-in-time interpreters, and self-interpreters. Interpreters are more suitable for smaller models where speed does not matter, whereas larger models would use compilers to meet memory-intensive needs. Both interpreters and compilers have their advantages and disadvantages. However, most software environments can employ both to fit their needs.